All right, let's dive right in. Today, we're talking about something that's at the very core of coffee roasting. How do you take an idea for a flavor and turn it into a concrete, data-driven plan? We're going to look at a Roaster Profile Synthesizer. It's a tool that basically takes what you want your coffee to taste like and translates it into a file your roaster can actually follow, from a simple vision to a machine's command.
I mean, this is the million-dollar question, isn't it? You know you want a coffee that's bright, maybe a little floral, with that awesome citrusy pop. But how do you tell a machine to do that? How do you actually translate that feeling, that taste, into the cold, hard language of time and temperature? Well, that's exactly the problem we're going to dig into.
So, let's start with the big idea here, going from a flavor in your head to a digital file you can actually use. And let's be clear, this isn't about replacing the art of roasting, not at all. It's about giving the artist a way better canvas to start with. Okay, this next part is super important to get. What this tool does is called profile synthesis. It's not a prediction. Look, this thing isn't a fortune teller, right? It's not going to magically know the humidity in your room or exactly how your specific roaster is feeling today. Instead, it generates a really smart, well-reasoned target. It's a hypothesis that you, the roaster, can then go and test. So you got to think of it less like a crystal ball and more like a really smart assistant. And you can see how this slots right into a professional workflow. It all starts with your intent. You've got this bean and you've got this taste in your head. The tool synthesizes that into a target file. Then you go do the roast, you record your data, and, this is the most important part, you cup the coffee. And this is where the magic happens. You taste it, you see what you got, and that feedback goes right back into the next roast. It's this awesome cycle, this loop of getting better and better. Okay, let's get a little geeky for a second. To make this whole thing even possible, the tool had to solve one very specific problem. It had to learn how to speak the native language of the one piece of software pretty much every roaster uses, and that's Artisan. Now this is the discovery that pretty much cracked the whole thing wide open. You'd think, okay, it's a data file. It's probably standard JSON, right? Wrong. Turns out Artisan's .alog files are actually a Python thing, a dictionary literal. See the difference? Single quotes instead of double, and that capitalized T in true. It's a tiny detail, but it is everything. Once they figured that out, it meant the synthesizer could create perfect files for Artisan without even needing Artisan on the same computer. Total game changer. And check this out. It doesn't just spit out one file. Of course, you get the .alog file, that's the one Artisan needs, but you also get a markdown file, which is basically your roast plan written out in plain English. And, maybe most importantly for us data nerds, a .csv file. That's all your time and temperature data, so you can really get in there and see what's happening second by second. Basically, it gives you the whole story, from the big picture down to the nitty-gritty. All right, enough with the tech talk. Let's see this thing actually do something. We're going to synthesize our first curve using a gorgeous, washed Ethiopian coffee. So this is where you can see that floral and citrus idea turn into actual numbers. Let's compare our target, that Guji G1 Ultralight, to a pretty standard light roast baseline. Look at the drop temperature. We're pulling it a bit cooler, down to 199. The development time is a little shorter too, and so is the development time ratio, or DTR. Every single one of these little changes is on purpose. We're trying to protect all those amazing, delicate flavors that can just burn away if you're not careful.
Okay, so that's our first pass, but what if we want to get even smarter about it? Let's bring in some big gun theory. Now we're going to talk about the Rao-informed refinement. We're going to see how we can build on our first curve by baking in some of the core ideas from, you guessed it, Scott Rao.
Now, a lot of people hear Rao and they immediately think DTR, development time ratio. And yeah, that's part of it, but it's not the main thing, not by a long shot. The real goal, the number one priority, is a smoothly, constantly declining rate of rise, the ROR. That's just the speed the beans are heating up. You never want it to stall or jump back up. DTR is a great thing to check after, but that smooth ROR curve, that's the holy grail.
So let's see what that actually looks like in practice. Compare our first ultralight profile to the new Rao-informed one. Okay, notice something really interesting. The drop temperature is exactly the same, still 19.9. We're still protecting those delicate flavors. But we hit first crack earlier, and look at the development time. We've almost doubled it, pushing it out to 2 minutes. The idea here is to run a very specific experiment. Can we develop more sweetness and body without losing that brightness we wanted in the first place? It's a calculated risk.
And here's the proof in the pudding. This is the data from that CSV file we talked about. Just look at that ROR column. From the moment we hit first crack at 7:30, that number just goes down, down, down.
7.7, 4.7, 3.3, all the way to the end. It's a beautiful, steady decline. There's no sudden drop-off, what roasters call a crash, and there's no weird jump at the end, which is a flick. This is exactly what we wanted to see. It's the data telling us we designed a really solid curve.
So what's the big takeaway here? Let's talk about the final piece, the roaster's feedback loop. Because really, the whole point of this isn't about the tool spitting out one perfect magical profile. It's about creating this amazing cycle where you're constantly learning and getting better.
And this is where it gets really exciting. The next big step is to completely close that loop. Just imagine this. You do your roast, and then you feed the actual data from your machine right back into the tool. You add your own tasting notes like a little grassy or sweetness is amazing. And the system looks at what you wanted versus what you got, and it learns. Then it spits out a new, revised target for your next roast. How cool is that?
And yeah, this image right here just says it all. This is the goal. It's about creating a personal learning engine for your roaster. A system where every single batch you make teaches the tool and you how to make the next one even better. It's completely customized to your machine, your beans, and your palate. And I think this is the most important thing to remember. A tool like this is never, ever going to replace a skilled roaster. It can't replace your intuition or your experience. What it does do is give you a much, much better map to start your journey. It lets you test your ideas faster, learn from your results more clearly, and just makes the whole process of discovery a little bit easier. It turns every roast into a chance to learn something new.